Welcome to the MS SQL Tips webcast, Practical Strategies for Getting High Performance in SQL Server High Availability Environments, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast organizer. If you have any technical issues with the sound or screen quality during the webcast, please use the question area to let us know. If you have questions during the webcast, you can submit them any time by entering your questions in the question area and your presentation controls. We will try to answer as many questions as possible in the time allotted during today's webcast. This webcast will be recorded and archived for future playback along with the slides, and you'll receive a follow-up email with the links. Our presenters today are Denny Cherry and Tony Tamarico. At this time, I'm going to turn things over to them and they can begin the presentation.
Thanks, Greg. Good morning, everybody, or afternoon or evening, depending on where you happen to be hanging out at the moment. This is Denny Cherry. You've got my contact info there on the screen. Morning, Tony. Thanks for joining me today. I don't know if Tony's got his mic turned on or not.
Oh, thanks, Denny. Thanks, everyone.
No problem, Tony. So here's a little bit about me real fast, in case you haven't seen this slide before. So I am the owner and principal consultant for Denny Cherry and Associates Consulting. I've written 6 or 7 books now. Mostly on SQL Server, including my solo book, Securing SQL Server, and was also part of the MVP SQL Server Deep Dives that was released about 2 years ago now. I've written bunches of articles on various websites. I am a Microsoft MVP for the SQL Server product. I am a Microsoft Certified Master for SQL Server 2008. I've been a VMware vExpert, and I am also a Microsoft Certified Trainer. So let's go ahead and dive into the slides, because I know talking about me isn't what everybody's listening to or looking forward to on this call. I'm sorry, it's 9 a.m. It's really early for me. So what is our biggest challenge when it comes to high availability? And one of the biggest ones is dealing with performance as that workload continues to increase. What the reason for that is basically because we don't have any real good way to get really, really high performing storage behind a high availability cluster. So obviously with always on availability groups in SQL Server 2012, this changes because we can now use local storage, but that's not what we're talking about, because that's a very, very, very small percentage of the world. What we're talking about here is everything else. SQL Server 2012 Standard Edition, SQL Server 2008 R2 and below. These things need high availability. They need it today, and they need high-performing storage to make these systems work at the levels that the business units demand of them. The business units don't really want to hear, well, we can't make the app fast enough because you've got high availability. They want things to go fast and to be highly available all at the same time. So how we have to deal with this is we have to deal with increasing I/O throughput. So we need to be able to get the data to the disk faster. One of the big problems with your traditional SAN storage is, while Fibre Channel is fast, Fibre Channel being the cable that sticks out of the back of your server that goes over, talks to a switch, and then that switch over to your big storage array. While that's fast, it's not always fast enough. You need to get data through that pipe a lot faster. Those Fibre Channel buses only push data so quickly. There is latency on those networks. While it's not usually that much, there is latency on them. And on top of being able to push more throughput through those networks, we need to simply push more IOPS through those networks. SQL Server does everything with these big fat I/O with 64K typically, and we need to get these blocks up and down to the disk faster. We need to get more of them per second through, and this goes back to the fact that Fibre Channel is only going to be so fast. You're only going to push so much data through this network to make it go quicker. And then we have the business requirement: make it being the operative word there, go faster. Whatever it is, the database, the application, whatever the performance problem that they're thinking about at that particular time, they want that to go quicker. So you really have to make it go quicker. And the way to do that is a lot of the times just faster storage. We can add indexes and make queries go quicker. We can, tune the system a little bit. But sometimes what it comes down to is simply putting faster storage underneath the system. And yeah, we can put flash drives in our big enterprise arrays, and those drives are a lot faster than typical, spinning disk. But that isn't always good enough. A lot of the times, we simply need much, much faster storage than we're going to be able to get in that networked environment. So our traditional options are basically add more spindles or faster spindles, and just repeat ad nauseum until you want to just kill yourself. And then eventually, with our hands, complain to the SAN team it's not going any faster, and just kind of live with it. This whole approach doesn't really work anymore. Spindles, spinning disks haven't gotten any faster in 15 years. I kind of rattled on about this ad nauseum during 24 Hours of Past. If you caught that presentation, or if you saw that recording, I remember getting my first 15K disks back in the late 90s, and those are still the same speed disks I can buy today. Nothing's really changed there. So basically that removes the faster spindles option out of the equation. Now we just add more and more spindles into the equation, and that's only going to do so well for us for so long. And eventually we're just going to need a faster solution that's going to be able to provide a lot more I/O and a lot more throughput than we're going to be able to get from this traditional storage architecture. So along with that, SAN storage is not cheap. If you want to go add a couple of shelves to your storage and throw another 30 disks at your problem, you could be easily looking at $60, $80, $90, $100,000, depending on who you manufacture and how much your components cost, what your contracts look like. So on top of that, what happens if the array is actually full? The frame or the array itself can only hold so many actual spindles. So once you've filled it up and you can't get any more spindles into the frame, what do you need to do now? Well, you need to now buy another frame, which means you're spending a lot more money. Suddenly adding that shelf of disks is going to go from $50,000 to $400,000 or whatever it costs to buy a frame from your specific manufacturer. And there's lots of other costs that go along with that. You need to add power, you need to add cooling, you need to add another rack into your environment. So if you're at a hosting facility or a colo facility, that's all money, because you need to buy the rack, you need to buy power drops from the provider, or you just need to have an electrician come in. But that means you're paying for that electricity month over month, year over year, just to make this thing go faster. And is that really going to be worth it to pay those hundreds of thousands of dollars a year, depending on how much your stuff costs, to get this stuff up and running and get it that incremental bit of faster? Because really what we're talking about when we're talking about throwing shelves of disks at things is making things incrementally faster, because it's probably already got a lot of shelves behind it today. So an example of this is a client I'm working with right now. They have, give or take, about 100, 150 spindles behind just their SQL Server. So if they want to add, say, 50% more I/O capacity, we'll say they've got 150 drives. If they want to add another 50% I/O performance to their application, that means they need to add 50% more disks at the minimum. Well, that's 75 disks at 15 disks per shelf. Suddenly, that's a lot of shelves that need to be added just to get that small increment of performance out of it. If all we add is another shelf, that's just 15 drives. So that, 7 disks out of RAID 10, it's about 1,000 additional I/O that they can throw at the system by adding a shelf, give or take. Not really the best performance for the amount of money that's going to cost in the long term. And I kind of beat on this a little bit earlier, in that the networks are only going to be able to pass that data through the system, so fast. It's going to take quite a bit of time for that data to get from point A to point B. And if that network starts to fill up, if we start pushing too much data between the switches and the array, for example, now again, we're talking big money to upgrade these environments so that we can get this level of performance we need. There's lots of little places that these things can bottleneck that become very, very difficult to try and troubleshoot. I literally just got done with an engagement last night with a client where we were trying to troubleshoot performance problems in their SAN environment using one of the big vendors, and we isolated it down to a specific appliance on their environment that was causing their latency. And it was adding 20 to 30 milliseconds of latency for each I/O that was coming through whenever it was having problems. So it was having big problems in their environment, but we still haven't been able to nail down the exact cause of that problem. We know where the problem is, but they're still working with the vendor to identify the root cause of the problem so they can resolve it. And while they're dealing with this, their business is being adversely impacted because they can't just throw money at the problem to make it go away, because this bottleneck is right in the middle of their environment. So they can't just throw spindles at it because the problem is between the spindles and the server. So there's all sorts of problems there. So this last bullet point just goes right back to what I was talking about a couple minutes ago, was the cost-benefit ratio may not be there when you're spending X number of dollars to get the performance that you need. You may be spending huge dollars to get the performance, but is that performance really worth the huge dollars that you're spending to get it there? If you're spending $100,000 to shave half a second off every screen pop in the customer service application, is that really worth it? If we're spending $1 million to get a half second, is that really worth it? We need to figure this out. And is it going to be worth it if we're going to have to spend that same amount of money 6 months from now to shave that second back off it again? Or does it make more sense to spend a little less money, get a totally different solution to migrate to, and then be able to just blow the doors off the business and go, okay, well, instead of shaving a second off of that 5-second screen pop, we've actually shaved 4.9 seconds off that screen pop, and it's going to stay there for the foreseeable future. That's a much better way to go with this problem than to go with the, let's just throw money at our traditional solution, because that's the solution we've always used. That doesn't necessarily mean that's the solution we want to continue to use moving forward. A lot of organizations I talk to are actually stuck in that problem. They're in this problem of, well, we've used SAN storage for years, so we're going to use SAN storage forever. Yeah, but what if that's not the right solution anymore? We need to kind of take these blinders off of, this is the solution we have, this is what we're going to use, we're going to throw as much money as possible at it, to this is the solution we have, and it works great for 85% of our environment. But for that other 15% of our environment, let's find the right solution to that problem. Now, this goes back to every religious debate out there in IT. Should it be SQL Server or Oracle? Well, it should be whichever one is going to work best for the solution. If I was building, let's say, an IBM WebSphere environment, I probably wouldn't want to put SQL Server behind it, because that's not going to be what it's going to work best with. It's going to work best with DB2, and then next choice would be Oracle. Don't tell Microsoft that; they'll get very upset at me. But just on the flip side, if I was building, say, a brand new Microsoft Dynamics environment, I'm probably not going to want to put that on Oracle. That's probably going to work better on SQL Server. So it's all about wanting to use the best technology solution for the specific problem at hand, instead of just shoving the exact same solution at every single problem you have, because that just doesn't work very well ever. So how do we make this whole thing go faster? That's obviously the whole point of this talk today. So the best way to do that is going to be PCI-based flash drives. These are going to be incredibly fast, Sorry, I was not expecting my calendar entry on my phone to make noise. So these PCI-based flash drives are going to be extremely fast, and they're going to really get you huge amounts of throughput and performance available to you. Now, this isn't the same kind of flash technology that you see in your typical USB thumb drives. It's much, much faster technology, and it's going to be able to take a much, much higher I/O throughput than you're going to see in your, in your traditional flash drives. And the reason it's going to be so much faster is because we're plugging it directly into the PCI bus here. So this isn't like your traditional SSD that you might have in your home computer, like I have sitting in my home computer, where it's just a regular flash hard drive, regular SSD hard drive plugged into your SAS port, because that's only going to be able to push about 6 gigabit a second. This is hooked directly to that PCI bus, so it is going as fast as that PCI Express port is going to be able to go. If you're on one of the newer PCI Express 3 buses, which is what you're going to want to put these Fusion I/O drives into, you're looking at 256 gigabit per second. So you don't have to do the math. That's 31.5 gigabytes per second, or 31.5 billion bytes per second that you're able to push down into the storage. Way, way faster than you're going to get with your 8 gig fiber channel port that you're using to connect to your traditional SAN today. Now, this isn't going to remove all bottlenecks, because we are always going to have a bottleneck when it comes to performance. Why won't my phone shut up? So all we're doing here is we're simply moving that bottleneck from the storage to how fast SQL Server can process the I/O. So basically, our CPU is now going to become the bottleneck. So as long as our code is clean, we're still going to run that processor at 100%, but we're not going to be wasting time with bad code, and we're not going to be wasting time waiting for storage. Once you throw these Fusion I/O drives in there, you should pretty much never see page latch I/O sort of things popping up in your wait stats anymore, because we just won't see those. The disk is going to be so fast that it's just going to be receiving that data and processing it way, way faster than you're going to be able to push those requests down to the storage. Now, that said, you may notice something about this card that you're looking at on the screen. It's a PCI card that you're plugging into the server. So, because of that, we do have one little problem. We don't have a good native high availability option, because this is just a card that's going to plug into the PCI port. And because of that, that means it's installed locally. So we need some sort of solution that's going to be able to talk between that PCI card and the other server that we're using as our high availability solution. So, whoa. Sorry, my PowerPoint just freaked out. Let me get back to the correct slide. I've never seen it do that before. There we go. So we need some sort of third-party block replication technology that we're going to be able to use to talk between two servers and replicate this data. Now, not only do we need to have a solution that's going to be able to do this, but it's going to need to be supported by Microsoft, because if we're going to be running our mission-critical databases on it, we obviously have to be able to call Microsoft and go, this is the solution we have. We need to be able to, get help. And if it's not a supported solution by Microsoft, the odds of getting help from them are slim to none. So that said, it also needs to be cluster aware, because we need to be able to get our traditional SQL Server clustering to work on it, because we can't upgrade every system to always-on availability groups in SQL Server 2012. Almost every one of my customers is still running the majority of their business on SQL Server 2008 R2 with no plans to upgrade in the near future. So that's the solution that needs to be supported. It would be great if I could tell them, yeah, sure, just upgrade to SQL Server 2012, availability groups, and everything will be fine and glorious. But unfortunately, we have to work in the real world, and so we need to support these environments where we're running these other versions of SQL Server. I mean, I've got customers that are running SQL Server 2000 still. The customer just has plenty of it on their site. So we need to be cluster aware, we need to be supported by Microsoft, and we need to support this this block level replication to get from one system to another. So there is a solution out there that's going to meet all of these bullet point requirements. Now that solution is Datakeeper Cluster Edition, conveniently enough made by our good friends at SIOS who are putting on this webinar today. So this is going to allow you to cluster your Fusion I/O memory devices. So you're going to have a Fusion I/O memory card in each box, or in 2 boxes, and then you're going to use the Datakeeper Cluster Edition to replicate the data from one box to another. We've got a really nice demo that we're going to do in a few minutes here, where Tony's going to show us how this actually works and the fact that it is actually clusterable and can work in a high availability environment that we all need for all of our boxes, and gives us the performance that we need. The only real latency we have to work with here is the network latency between your servers. So on your typical network, that's going to be a sub 1 millisecond environment. If you were really worried about any latency being added by a switch or something, I suppose you could even just plug a crossover cable, as long as it was fast enough, between those 2 servers. I'd recommend a 10 gig crossover cable, 10 gigabit crossover cable. And then that's your only latency, is that as the data travels over that cable. So that's going to be an extremely low latency network link, probably a lot lower than your typical SAN environment is going to be. And it's going to just simply push that data across the wire, and it's going to be written to another Fusion I/O device on the other end. So you're not going to have to worry about space and allocating storage or allocating runs or going to your SAN team to go get storage from your storage array. You simply pop that Fusion I/O drive in there and you're good to go. And because the Fusion I/O drives are the same size on both sides, this whole thing just works perfectly. Once you've got this Datakeeper Cluster Edition set up and running, you've now got fully cluster aware storage that you're working with. So the Datakeeper Cluster Edition, what it's doing is it's taking the 2 Fusion I/O drives, kind of mirroring them together, and presenting them to Windows as shared storage. Now this isn't a hack solution that's kind of been cobbled together. This is a Microsoft stamp of approval solution. So it's cluster aware, it's going to be seen as shared storage, it's going to be seen by the clustering services as shared storage that you can import into the cluster and use as shared storage within your Windows cluster. So you can get this thing up and running and put SQL Server on it just like you would any traditional SAN storage. It's not going to look any different, and it is a Microsoft certified solution. So if you do call in for support, which is obviously a big deal with a lot of environments, is that having that ability to do that, you're going to have that ability to call into support at CSS at Microsoft and get the support you need from the SQL Server team with this solution underneath. And of course, the best part of this whole thing is that it's going to give you the performance of the Fusion I/O memory cards with the high availability of SQL Server. So we get really the kind of the best of both worlds here as we're looking at having the performance that we need to really push through the IOPS that we need to get things done, and we have the availability to keep the line of business application up and running that 4, 5, 6 nines worth of time that we need and that the business is demanding. The reality is, in today's environment, most applications have these ridiculously high uptime requirements that we just didn't have a few years ago. On top of that, they've now got so much data that bringing them online for those periods of time is now extremely hard to do. And this is going to make it a lot easier to bring these solutions online with these high uptime requirements. So this is kind of the diagram of how this SANless cluster is going to work for you. So the environment that Tony's going to be looking at in a little bit is built on this exact Supermicro environment. And this is the same environment that I was using when I did some testing for them. And you probably saw a blog post about it up on SQL Server Magazine's blog. And I think I'm going to link to that on my next slide. So you can grab that URL there. So it's a Supermicro 2U twin server with dual Intel Xeon E5 2670 CPUs, 64 gigs of RAM per machine. So there's two servers basically inside this Supermicro 2U chassis. Each one of those has got a Fusion IO drive 2 with 1.2 terabytes of storage on it. And then we're using the SIOS block level replication with the Datakeeper software for our HA protection. So ignore the fact that it's a single device for a second and just think about the fact that it's two physical servers, each with a Fusion IO card and RAM and processor, and then a high-speed network link between them. In this case, they happen to be crammed into a single 2U case with redundant power coming out the back. So there's no SAN, there's no NAS, nothing special going on. So let's go ahead and look at the actual numbers that we got as part of this environment. So here's the link that I threw up there, so you can see, you can read the whole blog post if you haven't had a chance to read it yet. Now, normally in a high availability environment, you're not pushing massive I/O. That's just a fact. Unless you've spent huge amounts of money, and by huge I'm talking like 7-figure, multi-million-dollar, just to support that one application. You're not going to get multi-thousand I/O workloads going through the system. So in this particular case, when I was doing my testing, I was able to push over 12,000 read IOPS through SQL Server. And this isn't just one little burst that I was able to push through when I was doing this test. So if you'll notice the duration on that test down at the bottom there, this was not a short test. This was an almost 2.5-hour long test when I was pushing I/O through. So my average is a lot lower because the test harness doesn't just blast it with 12,000 I/O for the entire test range. But we were able to peak out at 12,000 I/O. Which is a very high number to be able to see in a SQL Server workload when pushing data through. Now, we weren't just doing a read-only workload. We were actually pushing write I/O through the system as well. So let's add that write I/O in, and we're adding in another 5,000 I/O of writes into the environment. And you'll notice the writes are basically pegging the system. Over the course of this 2.5-hour test, we were averaging 1,800 write I/O throughout the entire workload. And you can see at the bottom, half an hour of that was basically nothing. So that last half hour there dropped that average dramatically. So we were pushing 4,000 to 5,000 I/O consistently for 2 hours throughout this test harness, or throughout this test range. Now, the really important numbers here are the response time numbers. So let's take a look at what those looked like. Response time, basically 0. Maximum response time was 0.001 milliseconds. Minimum 0, average of 0. Now, these numbers look kind of spiky when you look at when you're looking at the actual graph. But one thing I want to point out is that I've adjusted the scale on this graph dramatically from what you would normally see if you pull up the average disk seconds per read counter in SQL Server. So if you look at the scale here, you'll notice that it's not set for the typical 1 or 10 or whatever the default is. I've actually got it set for 100,000. So looking at these numbers, remember we've got this maximum on the green line of 0.001 milliseconds. Now, I'm going to put my little laser pointer doohickey right here and point out that where this laser pointer is, which you should be able to see right about now, on the screen, that is the line across that screen for 0.001 milliseconds. So the bulk of the time it was below that for that read counter, for that red line. So they're at the same scale. So the green line is peaking at 0.001, so the red line is probably peaking at 0.002 and averaging well below 1 millisecond. So, I mean, the response time is basically nothing. So we were pushing the data back to the SQL Server as fast as SQL Server could request it. Now, the tests that I was running through this were some TPC, I believe, -C tests. I don't actually remember which test harness I use now. So it was a legitimate OLTP workload test. I wasn't just running, how many inserts can I throw at the SQL Server at once, or how big, if I run one big query, just do Cartesian joins against, joining the table to itself, and reading a ton of data. Now, so I was running an actual OLTP workload, so we were actually hitting the disk relatively hard, and still getting these really, really good numbers back from the storage. So you don't have to use the 2U device that Fusion IO has. You can have this sort of configuration with really any hardware. So for example, we could take 2 normal Dell servers, drop a couple of Fusion IO cards in there, drop the SIOS software on top of that, and then suddenly we get the protection and performance of the Fusion IO with the high availability requirement that we need, and give the business what they need at a very, very reasonable cost for the units, and to get this solution up and running. So I'm going to go ahead and hand it over to Tony. I know it's a couple minutes earlier than I told him it would be, but I want to go ahead and let Tony show you the SIOS environment and the Fusion IO environment, so you can see exactly what we're talking about here with this sort of environment. So Tony?
Excellent. Thanks very much, Denny. So as Denny mentioned earlier, traditional Microsoft clusters have always had that dependency on shared storage, which represents cost, complexity, but what a lot of people don't think of is that the shared disk also technically represents a potential single point of failure. Now, these SAN-based solutions are generally very robust, but it is possible that it could have an issue and the storage could become unavailable, and that just basically takes down the entire cluster. It doesn't matter if you have 2 nodes or 10 nodes in a cluster, you've got no data, so your application is dead in the water, your SQL database is down. So in today's quick demonstration, I'll be showing you what a SAN-less cluster looks like. I also will sometimes refer to this as a shared nothing cluster because there's no shared disk involved. And specifically how Datakeeper Cluster Edition from SIOS provides this cluster integrated and aware real-time block-level data replication, which now gives you that option to create a SQL cluster. And this works with any application for that matter. It could be file share, could be Hyper-V cluster, you name it. But the ability to now create a cluster without that shared storage requirement anymore, which works very, very nicely. Very nice complement to the Fusion IO technology, so you get the performance from Fusion, but it's local storage, so we enable them to be clusterable here. So in today's demonstration, I'm going to review how to create a mirror to replicate the local disks in each system, and show how that mirror is automatically then presented to the cluster as a cluster disk. So let's jump right in. So I've got a simple 2-node cluster here. My nodes are called primary and secondary. And I have a couple of clustered services and applications. And for anybody who's set up a SQL or Windows cluster in the past, you already know 95+% of this solution. So your day-to-day life isn't going to change. The features and the functionality and the protection that you gain from this SQL cluster, that's all preserved. We're just simply eliminating that shared storage requirement and allowing this to now happen with local disk. So you'll notice that there are 2 differences in the cluster configuration. The first one is we take a look at the quorum configuration in a cluster with an even number of nodes. If you had a SAN you would generally go with, you would have a quorum disk, and your quorum configuration would be node and disk majority. But in a configuration where there literally aren't any shared disks, that's where you would go with this other option that Microsoft provides to you, and you would set up the quorum type as node and file share majority. So instead of a quorum disk, you use a file share as part of the quorum configuration. Now the second difference that you'll notice is in the storage pool. So in your traditional SAN-based cluster, you would see, cluster disk 1, cluster disk 2, cluster disk 3, and so on. And those are called physical disk resources. Those represent the shared LUNs on your SAN. But in this type of a configuration, again, we don't have any shared disk. So that's where Datakeeper comes into play. We've implemented our replication technology as a Windows filter driver. So that's how we sit beneath NTFS. We intercept the writes as they come down, and one copy of the block goes to the local machine, and the second copy of the block goes across the network to the standby system, to the target side of the mirror. And that all just happens seamlessly. So think of it like a RAID 1 or a software RAID just across the network now. So the way that it looks and feels and behaves is almost as if you took two drives, put them in the same server, went into Windows Disk Management, and created a software RAID. And you've got that level of data protection, but now these two drives are in different servers connected across the network. And the second component of this is our cluster integration. So this is all cluster aware, and you can see here in the storage pool I've got these Datakeeper volume resources. So here I've got a Datakeeper volume E and a Datakeeper volume F. So it looks and it feels and it acts like two different shared disks. In reality, it's an E drive on primary and an equally sized E drive on secondary. Same goes for F. I have equally sized F drive on both of these two servers, and Datakeeper is keeping them in sync in real time and presenting those independent disks to the cluster as shared storage. So what I'll do next is show you how we got this set up into the cluster. It's very easy to do. I'm going to switch over and bring up the Datakeeper user interface, which is just a standard MMC snap-in. And this solution supports Windows Server 2003, 2008, and 2012. So you can use whatever version of Windows and SQL that makes sense for your business here. What I'm looking at right now is called the Server Overview Report. This is kind of a nice bird's eye view that tells you what servers are involved. I can see here primary and secondary. I can see the different drive letters that I have configured on these machines. And two of the drives have already been mirrored. I've got my E and my F volumes that are already being replicated. And you can see what role the servers play in the mirror. So right now, primary is a source for both E and F. So data is replicating from primary over to secondary. Each mirror, though, potentially could be replicating in a different direction. So if you have a SQL cluster with multiple SQL instances, you might have one SQL instance on primary and a different SQL instance running on the server called secondary, where they're each essentially a backup for one another. So it doesn't have to be a pure active-passive cluster. If you have different workloads, they can run on different nodes in the cluster to spread things out here. So I'm going to create a new mirror. We call it a job in the Datakeeper interface. And I'm going to replicate this R volume, which right now isn't being mirrored. So it's very easy to do. I simply click Create Job and give it a name. I'll just call this R drive and an optional description. Now this is a three-step wizard to get this disk, first of all, replicated in real time, and then also registered into the cluster as a cluster disk. So in step 1, I pick my source. Step 2 is pick my target. And step 3, I select mirror options. So it's that simple. So my primary machine, or source machine, is called primary. I have the ability to select the specific network that I want to use for replication. So as Denny mentioned before, most commonly people will have a 10 gig NIC between these two because you want to make sure you have enough bandwidth so that we can push the data across the network as fast as you write it to the local storage. And these Fusion I/O cards are very, very fast. So generally speaking, a 1 gigabit NIC, those cap out at around 120, 125 megabytes per second of throughput. These Fusion cards can write much faster than that. So you want to have a network connection between the two servers that can support the rate of change that you'll be putting on these servers, specifically the writes. Reads don't change any data, obviously, so nothing needs to be sent across and replicated, but when data is written, we want to replicate that data to the other nodes. You've got full data protection here. So in this example configuration, I've got network interface cards on different subnets. I've got my 197 subnet, that's my quote-unquote public interface, and I've got this 198 network, that's my back-end crossover cable that I use specifically for replication. And then you go ahead and you select the drive letter that you wish to replicate. So I'll select R and click Next. Step 2, I select my target. And you'll notice that this has been pre-populated for me. It knows what the other machine is. It's selected the IP address on the same subnet, and it's selected the same drive letter. So typically, you don't ever have to change anything on this screen. And finally, you select some mirror options. So we support both synchronous and asynchronous replication. Generally speaking, if you've got a high-speed, low-latency network, like a local area network setup, single-site type deal, you're going to go with synchronous replication. Now, if you did want to set up a geo-cluster where you've got, let's say, one cluster node in San Francisco and the other cluster node in New York City, and you've got some decent amount of latency across the network, then that's generally where you would select asynchronous replication. So we support both modes, and you can select what makes sense based on your network infrastructure, as well, combined with your company's RPO or recovery point objectives, meaning how much data loss are you okay with, or or you can't have any. So synchronous replication ensures zero data loss because it is a double commit on both sides. The write isn't acknowledged as completed until it's made it to both source and target system. So I'm going to go ahead and click Done, and it's going to create the mirror. Also on that previous screen, we do have built-in options to set bandwidth throttling as well as compression. Those are typically features that you only turn on if you're doing a wide area network, a geo-cluster type setup here. And we are presented with a question. It says, great, I've just successfully created this brand new mirror, and I've detected that you've set this up on nodes that are part of a cluster. So as a convenience, would you like me to register this as a cluster disk into the available storage pool? I'm definitely going to say yes here. You can always add it in later if you wanted to, but it's just so convenient to do it this way. So now if I go back into the failover cluster interface, I've got this brand new Datakeeper volume R that was just automatically added in the cluster. So it's literally that three-step wizard. You pick your source, you pick your target, and you pick your mirror options. At this point in time, that pair of R drives that Datakeeper is replicating in real time just shows up into the cluster as a cluster disk. And from here, your life as you know it in Failover Cluster Manager is the same as it was in the past when you had a SAN. So it looks and it feels and it acts like shared storage. So now you install your SQL instance, and during the SQL installer, we're asked you which cluster disk do you want to use. You just check the box next to, for example, Datakeeper Volume R. So none of that changes. Also, the way that switchover happens or failover happens, none of that's different either. So I'm just going to move a resource. I've got a couple of resources here in my cluster. I'm going to move one of them to the other node. So I right-click and move it to secondary, just as you normally would. Confirm that I do want to move it. And it's going to switch over the resource. It's going to move the IP address. It's going to switch over the disk as well and start up the services. Now, in a SAN-based configuration, it would basically online and offline the disks accordingly and place a SCSI reservation to lock the LUN and those types of things. Well, here where there's no shared disk, what it's doing under the covers is it's telling Datakeeper to do a mirror switchover. So this F volume was replicating from primary over to secondary. Well, now the Datakeeper F volume is active now on secondary, so the mirror was automatically switched. If I go back into Datakeeper, I'll see that that change was reflected here as well. So F is now source on secondary and target on primary. So the role reversal of sources and targets, basically all this mirror management, happens automatically. It's all driven through the cluster. You don't need to worry about, well, when SQL moves from one node to the other, you don't need to go in and do anything to tell data to replicate in the right direction now. And at this point, I actually have data replicating in both directions. I've got my E and my R drive replicating one way, and I've got my F drive replicating in the other way. So I hope that gives you a brief overview about the solution. The key takeaways here are the Datakeeper enables you to form a Microsoft cluster without the shared storage requirement, and this is an excellent complement to technologies like Fusion I/O drives that provide extreme performance gains, but they're local. They sit inside the machine. They're local storage, and on their own can't be used as part of a cluster configuration. So this just kind of combines the glue that pieces this all together, and now you get both the performance gains from enterprise flash as well as 100% data protection. So with that, I guess I'm going to stop showing my screen here, and we'll turn it over back to Denny and Greg to see if there's any questions or any additional topics that want to review here today.
Yep, there's definitely some questions. Thanks both Denny and Tony. We'll get through the questions here, and
yeah, so,
I'll just throw them out there. You guys can answer whatever questions are relevant to you guys. So the first question here is a question about cost. So somebody's currently on SQL Server 2008, and they want to move to 2012 using always-on availability groups, and they're just wondering, is it a cheaper solution going with the Datakeeper route versus going to 2012 having the upgrade?
So this is definitely going to be a cheaper solution for you, because if you're going to be going up to SQL Server 2012 to use always-on availability groups, you're looking at Enterprise Edition. Always-on availability groups have an Enterprise Edition solution, or an Enterprise Edition requirement, rather. So it's going to be much, much less expensive to stay on 2008 and move up to using the Datakeeper solution to push your I/O to the limit, just because you can stay on your existing platform. You can do it with probably minimal downtime, since you're not doing any sort of version upgrades. You realistically don't need to do hardware upgrades. All you need to do is basically down all the nodes of your cluster, put the Fusion I/O drives in, install the Datakeeper software, and then get that mirroring set up that Tony just showed you how to do. Then just basically drop your database files on it. So that's your big outage, is to move your database files onto those Fusion I/O drives, and then just bring the database back online. So your biggest outage time is going to be how long it takes to physically copy those files from your existing storage to your Fusion I/O drives on local, all within the local drive, with the local machine, so you don't have to push it over the network or anything like that.
Excellent, Denny. And if I can add a little bit to that, in addition to the cost aspect, there's also a protection aspect as well. With availability groups, it's protecting certain databases, certain user databases, where by setting up a configuration with Datakeeper, where you're ending up with a failover cluster, a clustered instance of SQL, and we're protecting the entire instance. So availability groups isn't going to protect things like your system databases, master, MSDB, your SQL logins, your SQL agent jobs. Those things you would need to maintain and keep in sync yourself. So with the Datakeeper solution, because we're doing the replication at the disk level, everything gets replicated, everything gets protected and failed over. Just like, again, if you had that SAN, but now we're doing this with regular disk. Also, certain applications aren't compatible with availability groups if they rely on distributed transactions and things like that. There's also a performance aspect. Because we're doing this at the block level, we have a very, very efficient replication engine that can get the data across the network honestly quicker. So a lot of benefits to doing this way, both cost, protection, and functionality.
Okay, next question. This is actually for Denny. This goes back to the slide you had, Denny, with the graph, and somebody just commented, and I guess I should have asked you this earlier. The graph showed that the reads were slower than the writes, and I think you just can explain if there's any explanation to that. I don't remember the numbers. We did more reads than writing.
Yeah, let me throw that slide back up there so you can see what the picture we're looking at. Yeah, that'll be the one. So I don't know the exact reason that the reads were quicker than the writes. Tony, you probably know more about the internals of the Fusion I/O drive than I do. I also didn't correlate the amount of data I was reading with what these latency numbers were. I just never had time to because I had to go run off to a client site for 2 weeks. So I suspect that we were I know we were reading more data than we were writing, because looking at this graph, and this graph specifically, we can see the reads were peaking at 12,000 ops, whereas the writes were only peaking at 5,000. So we were pulling more data up than we were pushing down, which would explain probably some of the latency differences between reads and writes that we were seeing here. Tony, would you agree with that statement?
Yeah, it just seems like the workload that you were running was potentially heavier on the read side than the write side. Also, keep in mind that in this setup we were doing synchronous replication. So the reads, there's always going to be a little bit of overhead with that, and that's a trade-off. That's a trade-off between synchronous and asynchronous replication. So with synchronous replication, when the write is made to the disk on the primary machine, the write isn't acknowledged as completed until it's been written to both servers, both disks. So you do have some round-trip latency between the machines that is a factor. That doesn't come into play with reads, because reads just go straight to the local server and nothing across the network happens, right? But the upside of the synchronous replication is there is zero data loss. With asynchronous mirroring, well, the write will go down immediately, and then there could be some in-flight data that maybe is across the wire. If you had a hard failure of the primary server, maybe it hadn't made it yet to the secondary node. But again, in a very high-speed, low-latency network, that window is going to be very, very, very small. Typically, asynchronous replication is used across wide area networks and things like that. So that really comes down to, hey, it's a data protection. Data protection versus performance kind of argument, and generally people always go with, I'm okay with shaving off just a little bit of write performance for 100% data protection through synchronous replication.
Yeah, and do keep in mind the workload I was running was a TCP OLTP workload. So an OLTP workload is going to be heavier reads than writes. So that's going to be one of the reasons that the workload that I ran looked the way it did, is because if you think about just your normal line of business application, you write, say, a loan application into the system once, but then it's going to get read 70 different times as it's going through its approval process. So that's how the TCP workload, or TPC workload rather, is written, is to kind of simulate that sort of thing. So that's why those workloads were being pushed the way they were.
And we've run other workloads. For example, we had a script we call our SQL Slam Test, and it's not a very real-world, realistic workload, but what it does is it inserts rows into a database just as fast as possible, just slamming the database to really test out the write scenarios here. And as an example, on some of these Fusion IO enabled servers, natively without any replication going on, we were able to achieve over 1 million row inserts per second. And then with 2 servers with synchronous Datakeeper replication, we were, had minimal overhead, and we were able to still push down, I'd say probably about 950,000 row inserts per second. So, 10% or so overhead with synchronous replication. Doing that same workload with availability groups turned on, we were only seeing, let's say, 250,000 row inserts per second or so. So pretty significant difference. We've done a lot of work over the past couple of years to really optimize the replication engine for high-speed disk environments, like this. And again, really the key is having that very high-speed, low-latency network between the 2 machines. That data can be pushed across just as fast as it gets written.
Okay, great. Thanks, guys. All right, the next question here is related to distributed transactions, and the question or statement is that I guess always-on availability groups don't support distributed transactions, and they're just wondering, does Datakeeper support that?
Yes, it does.
Yeah, so Datakeeper supports anything that works in a traditional SQL cluster. So MSTTC, or Distributed Transaction Coordinator, is obviously supported in a cluster. So it's going to work beautifully on top of the Datakeeper solution, rather.
Okay, great. The next question here is related to replicating system data, so system tables from master, MSDB, etc. And that always-on availability groups doesn't allow you to do that. So the question is, this is something that Datakeeper does for you.
Yeah, and this is, so Tony alluded to this earlier when he was doing the demo, the fact that this is, again, just traditional Windows clustering. So we are protecting everything in the instance on this super high-speed storage. So as long as you put your system databases onto your Fusion I/O drives, then they're going to be protected by the Datakeeper product and replicated between nodes, just like they would be if you put them on much slower storage in your traditional SAN storage.
Okay. And then, Tony, this is a question for you. When you're walking through the wizard setting it up, somebody just asked, is there command line scripting utilities that can be used as well?
Yes, there is. So, there's commands to create mirrors, switch over mirrors, lock, unlock, pause, continue. Yeah, basically everything you saw in the GUI there today, there's a command line equivalent to do so. So if you wanted to automate things, you can easily do that. It's all in our documentation.
Okay. Another question here from somebody is about using the Fusion I/O cards for TempDB. Is that something that would make sense?
That would absolutely make sense. So if you're in a SQL 2008 or below environment, obviously you have to put your TempDB on shared storage. So this gives you a fantastic way of putting that TempDB on shared storage to get the performance that you need out of it, without having to put it on your traditional SAN, which is going to be obviously a lot slower. So it makes perfect sense in a lot of scenarios to put your TempDB on, the sort of high-speed storage that goes along with these devices.
Okay. The next question here is related to failures. Let's say one of the nodes goes down, and the question is, do all the transactions get queued on the other node until the node that went down comes back up?
Okay, that's an excellent question. So we have a mechanism to protect against that. So you've got node 1 and node 2, and node 1's active, and let's say node 2 goes down because you've done some patching and need to reboot it, or perhaps the network cable between the two went out for some reason, but something interrupted replication. Yet your SQL Server is up and running, and data is being changed and all of that. So Datakeeper maintains a bitmap file. This is a statically sized file. Think of it more like an array or a pointer, where each bit in the file corresponds to a block on the volume that we're mirroring. And inside this file, we're basically flipping bits. We're tracking which blocks have changed and are out of sync versus which blocks are unchanged and in sync. So when that network connection comes back online, when the server comes back up, the replication will automatically resume, and the bitmap file knows exactly what the delta is. So we make the resync process, it'll be a partial resync. So there's, unless you lose an entire disk and the disk is never coming back, there's really never a scenario where you have to do a full resync of the entire data set. But, in that scenario, if you lost, let's say, the target side of the mirror automatically goes into a paused state, and that bitmap file is key in tracking the delta to make sure that the resync process is optimized once the mirror resumes. So oftentimes I get asked, well, if you're doing synchronous replication, it's a double commit. Well, if the target server goes down, does all my I/O just hang? The answer is definitely not. The mirror detects that automatically, and the mirror automatically goes into a paused state so that, operations happen, unaffected, and we track the data that's being changed so that we know what to replicate when it comes back up.
Okay.
I hope that answers the question.
All right. The next question here is related to using VMware. So the question is, can this configuration be set up with virtual machines, or does it have to be a physical box?
Sure, I can take that one. Yeah, this can work in either physical or virtual environments, or even cloud environments. So you can set up a so the Datakeeper solution is just software. The Fusion I/O cards can be installed in the physical servers, but that physical server could be running SQL natively on the OS, or you can put Fusion I/O cards into VMware systems to accelerate your virtual machines, and then perhaps inside the virtual machines then you create a, let's say, a 2-node VM to VM cluster. So that it's all possible.
Okay, great. We're almost out of time, so let's just take one more question and we'll wrap things up. So the last question here is, can Datakeeper be used with other storage, or does it have to be Fusion IO?
Good question. So we are storage agnostic, so we can work with any storage, any block storage. So as long as the storage in question appears to the operating system as a block device and you give it a drive letter, then it's good to go. This is just, we do this with Fusion IO very often because we have lots of joint customers. It's a very, very complementary solution where people want the performance gains, but they don't want to sacrifice availability, so this is just a natural fit. But this Datakeeper solution will work with any storage.
Great. Okay, well, thanks, Denny and Tony, excuse me about that, for today's presentation. A lot of great information. Also want to thank SIOS for sponsoring today's webcast. Also want to thank everybody for taking time out of your day to join us today. Just ask that when you exit the webcast, you can just take a couple minutes and fill out the survey. That helps with today's webcast as well as future webcasts. Once again, thanks for attending and hope you all have a great day.
Great. Thanks, everyone.
Thanks, Greg. Thanks, everyone, for coming.